The planning team can release a schedule correctly. Production can still be unable to receive usable work. Who owns the work during that interval?
Man, that is the absolute definition of an operational gap right there.
It really is.
And, establishing exactly who holds that space is it's critical. But to be clear, right from the start, our deep dive today is strictly about the ownership of the transfer itself.
Right.
We are absolutely not here to assign blame between departments or try to figure out who is at fault when things slow down. It's entirely about understanding the mechanics of how work moves or fails to move across boundaries.
And that is the core of our mission today. We are pulling insights directly from field note number 029, and that's supported by engineering field reports.
Yeah.
We've also got management studies from McKinsey and the Harvard Business Review, plus some really interesting analyses on industrial automation and construction facility management.
It's a lot of ground to cover.
It is, yeah. But the goal isn't just to, look at data. The goal is to figure out why work gets stuck in these invisible spaces between perfectly well-functioning teams.
Exactly.
And, more importantly, how to make that unowned space inspectable for you, the listener.
And that transition from invisible to inspectable, that is where the real leverage is.
Definitely.
Because the fundamental tension you just introduced, it doesn't exist because people are failing at their core jobs.
Well,
it exists because of how organizations structurally define completion.
Okay, let's unpack this.
Yeah.
Because I want to zoom in on the floor to see why this illusion of completion is so powerful. Let's look at the boundary between a planning department and a production floor.
Right, a classic boundary.
Right, in a local view, like inside the silo of a single department, everyone genuinely feels they are doing their job correctly. The planning department's entire mandate is to generate and release a schedule.
That's their whole world.
Exactly. They crunch the numbers, they look at their metrics, they see the schedule is published on time, and they just mark their task as complete.
Well, yeah, they've satisfied the parameters of their specific domain. Why wouldn't they think they're done?
But I've seen this play out. Production cannot actually execute that schedule without confirmed material availability on the floor.
Oh, absolutely.
If the raw materials haven't physically arrived at the staging area, that beautifully released schedule is literally just a piece of paper. The planning team is, celebrating a win, but the production team is completely paralyzed.
Which means the work is technically scheduled, but operationally stationary.
Right.
And if we move down the line to the next boundary, let's say from production to quality, we see the exact same local perspective repeating itself.
How so?
Well, production finishes the physical assembly of a unit. The machine is built, the product is in the box, or the chemical batch is formulated. Production looks at their dashboard and sees the physical output is complete.
They can point to it and say, there it is.
Exactly. However, the quality department cannot inspect or release that output without the required evidence.
You mean things like the test data, the material certificates, the batch records?
Precisely. Production feels they are done because the physical object exists in space. But quality hasn't even begun because their prerequisites are missing. The physical reality and the documented reality are totally out of sync.
It's like playing tennis without a net.
Yeah, that's a good way to put it.
I mean, you can hit the ball as hard as you want on your side of the court, but if the infrastructure to validate the point isn't there, the game just doesn't advance. And we see this heavily in the maintenance and operations boundary, too.
Oh, all the time.
Maintenance finishes repairing a critical piece of equipment. Let's say it's a centrifuge. They fix the motor, they close the assigned work order in their maintenance system. For the maintenance technician, the job is an absolute success.
Ticket closed.
Ticket closed, exactly. They're moving on to the next ticket.
But operations cannot safely run that equipment without an agreed release condition.
Right, like, has the machine been sanitized? Are the safety guards back in place? Has a test run been completed and verified by an operator?
Usually the answer is no.
Right. Until operations accepts that equipment back into their reality, the maintenance intervention, no matter how technically perfect it was, hasn't actually delivered value to the system.
And this is why we have to deeply test this assumption of completion. Why do these gaps happen over and over again?
Why do they?
They happen because each function reasonably believes it has fulfilled its responsibility. The sender finishes the task, updates their local system, and implicitly assumes the receiver is ready and waiting to take possession.
Right, they just assume the next guy is standing there with a catcher's mitt.
Exactly. And conversely, the receiver assumes their responsibility only begins when the work arrives fully usable, perfectly packaged, and accompanied by all necessary prerequisites.
So they are both right locally.
They are. But globally, the system is actively failing.
Because local success definitely does not equal system success. Let me bring in some evidence from our IFMS source on construction to facilities handover to really ground this.
Oh, this is a great example.
It really is. Imagine a massive commercial construction project. The construction team and the engineers deliver a state-of-the-art building on time and on budget.
A massive win.
From their local perspective, it is a massive victory. They hand over the keys. But they hand over those keys without organized as-built drawings, without complete equipment manuals, and crucially, without hands-on system training for the facility management team.
So the building is physically complete, but operationally, it is a massive liability.
Exactly. The facility management team receives this incredible building, but without that critical knowledge transfer, they are immediately forced into a reactive mode.
Just fighting fires from day one.
Literally and figuratively. The IFEMA data shows this leads to system inefficiencies that drive up energy costs and increased downtime because no one knows how to properly maintain the new smart HVAC integrations.
Right.
It even creates safety and compliance risks. The construction team won their local game, but the facility operations team is losing from day one.
What's fascinating here is that the delays and the risks do not happen inside the departments.
Right, the construction team didn't fail at construction.
Exactly. And the facilities team didn't fail at facilities management. The failure occurred entirely in the unowned space between them. And since local metrics don't capture that delay, we have to shift our perspective.
We have to look at the whole board.
We must look at how the entire system views a transfer rather than how the individual departments view it.
Because if we only look at local metrics, we are completely blind to the gap. So how does the system actually view a transfer?
Well, from a system view, we have to stop using the word done.
Oh, really?
Yeah, we have to distinguish between 4 distinctly different states of work that organizations dangerously treat as equivalent.
Okay, what are they?
The first state is completed by sender.
Yeah.
The second state is ready for transfer. The third state is accepted by receiver. And the fourth state is usable in operation.
I want to challenge that slightly.
Go for it.
If a design team finishes a schematic and they check all their internal boxes, shouldn't that just automatically be ready for transfer? Why do we actually need to separate state 1 and state 2?
Because the sender's internal boxes rarely account for the receiver's external needs.
Ah, I see.
Yeah, if the design team completes the schematic, that's state 1, but that schematic is missing the material tolerance specifications that engineering actually needs to build it, it is not at state 2.
Because it's not actually ready for a transfer.
Exactly. Yet, because the design team treats state 1 and state 2 as the same thing, they pass it along anyway. Ambiguity thrives when those 4 states blur together.
That makes a lot of sense. You're saying work can be completed by the sender, but technically unreceivable.
Yes.
This perfectly aligns with the choir source, which discusses the concept of silent handoffs. This happens when the sender thinks they are at state 2, they release the work into the ether, but the receiver doesn't actually know it is their turn to pick it up.
Or maybe they do see it, but they immediately realize it's missing those material tolerances, so they just don't accept it.
Right. And importantly, they often don't communicate that rejection. They just leave it in the inbox.
Just parked in a quiet gap.
Exactly. There's no meeting scheduled to fix it, no urgent email, just a silent void where the work is supposed to be living. And the choir analysis notes that this is the single most common cause of timeline slippage in cross-team projects.
It's wild because it's almost invisible.
It really is, until you look at the master dashboard a week later and realize nobody has touched the task.
And it remains invisible because our management systems are overwhelmingly designed to track work while it is active inside a department, not while it is parked between them.
That is a great point.
If we look at the data from the Harvard Business Review, the scale of this problem is staggering. The average cross-functional project has over 4 major handoff points.
4 major ones.
And each one of those handoff points adds a 20% or greater risk of delay if it is not managed deliberately.
Over 20% risk per handoff. If you have 4 of them, that compounds incredibly fast. You aren't just risking a day here or there. You are risking the entire viability of the project timeline strictly due to the transition phases.
Absolutely. And it isn't just time that is lost in that silent gap. It is data.
Right.
The Lean Six Sigma Hub source provides a critical metric here. Roughly 30% of critical information fails to transfer during interdepartmental handoffs.
Wait, 30%? Why does that happen, though? How do you just lose a third of the information if it's written down?
Because a massive portion of operational knowledge is never written down. It exists as context.
Oh, I see.
It is the assumptions, the rationale behind a design choice, the verbal agreements made on the floor. When work crosses a boundary, that context evaporates.
Just poof, gone.
Gone. 30% of the information vanishes, making it impossible for the receiver to reach state 4 usable in operation without initiating a massive cycle of rework, clarification, and reverse engineering.
That perfectly highlights what happens when state 1 is mistaken for state 4.
It is a devastatingly accurate way to look at it. The local work might be correct, but the system integration fails. And that brings us to the behavioral contradictions we see in the real world as a result of this exact ambiguity.
Right, because we have this massive system-level gap. But how do organizations actually behave when they're stuck in it?
Well, when responsibility belongs to everyone, acceptance occasionally develops scheduling difficulties.
Yeah, I think anyone who has ever sat in a corporate alignment meeting just felt that one right in their chest.
It is highly observable in almost any corporate environment. You will see project teams hold 90-minute meetings to discuss the lack of ownership, to map out the highly collaborative nature of a project, and to emphasize that everyone is accountable.
Lots of buzzwords.
Lots of buzzwords. Yet they will adjourn that meeting without assigning a single named individual to actually own the acceptance of the transfer.
It's the illusion of progress. We also see this in corporate processes that require multiple layers of sign-offs.
Oh, definitely.
You might have a document that requires a digital signature from marketing, a signature from legal, and a signature from compliance. You have 3 approvals, but 0 actual acceptance of the operational reality of the work.
That is such an important distinction.
Approving a document is fundamentally different from accepting responsibility for the usable outcome of that document. The work remains technically complete on paper, but operationally stationary.
And the visual example provided in our source material illustrates this macro versus micro contradiction perfectly.
The one in the maintenance plant room.
Yes. Imagine a highly serious maintenance meeting taking place in an immaculate premium plant room. You have 4 experienced professionals standing around a mobile work table.
Serious business.
Very serious. They are deeply focused, studying a massive central compressor control panel. They are likely discussing a system-wide pressure drop, formulating complex technical hypotheses, and preparing to make a massive system correction at the master regulator.
So they're looking at the macro, the grand system level.
Yes, and while they are standing there having this very serious engineering discussion, they are completely unaware that the wheel of their own mobile table is sitting directly on a small local air hose.
Just pinching it right off.
Pinching it and causing the exact restriction they are trying to solve. A massive system-wide correction is being applied because a small local handoff point, the physical reality right at their feet, is being ignored.
We build these massive, complex project management frameworks and hold sweeping strategy meetings, completely missing the pinched hose between 2 departments where the actual flow of work has stopped.
Exactly.
We ignore the unknown interval and then wonder why the entire system is starving for pressure.
Which is precisely why we need a way to look at the pinched hose. We need to transition from observing the delay to actually diagnosing the gap.
And that brings us to the diagnostic tool derived from Field Note 029. We call it the Handoff Ownership Check. Now, we need to explicitly note that this is a writer-developed framework based on the field note. It is a diagnostic tool, not a validated industry standard or some kind of magic bullet, but it is designed to do one specific thing: make that invisible, unowned space inspectable.
It converts an assumed transition into an observable decision.
Exactly. The Handoff Ownership Check breaks down into 7 specific criteria. We are going to explore each of these because the underlying psychology here is what separates a successful transfer from a silent handoff.
Let's do it.
Let's start with the first criterion: identify the sending owner. This must be a named person accountable for sending the work, not a generic team.
Because if the sending owner is listed on a workflow diagram as engineering or the design team, the check has already failed.
Why is that?
When you name a department, responsibility diffuses. The psychological weight of accountability evaporates. The specific question a team should ask here is, if this transfer lacks information, whose specific desk do I walk to?
You want a point of origin.
You want the person who cannot look away. It becomes observable because there is a single name attached to the outbound work. They are personally accountable for the handoff being complete before it is pushed across the boundary.
Which naturally leads to the second criterion.
Yeah.
Identify the receiving owner. And again, this has to be a named person, not a department. But specifically, a person authorized to receive the work.
That authorization part is key.
Why is the authority piece so critical here?
This directly addresses the choir source's finding on why cross-team projects break down into silent handoffs. If you just toss a task into a department's shared digital queue, it sits there.
Right, because nobody wants to touch it.
Because no individual feels the authority or the urgency to claim it. The question to ask is, who specifically has the authority to look at this inbound work and declare that it is usable for our department?
So it's not just about assigning a task. It's about assigning the authority to accept. If the receiver isn't authorized to say, yes, this is ready, or no, this is insufficient, then you don't actually have a receiving owner. You just have a passive inbox.
Correct. Without an authorized receiver, the work is stranded in state 2.
Now, for the third criterion, which is where things get really concrete, define ready-to-receive conditions. What specific observable state means the work can be handed over?
We are moving from assumptions to hard evidence here. The sender's definition of done and the receiver's definition of ready must be perfectly aligned.
They have to match.
Exactly. You have to ask, what exact measurable condition proves this is ready for the next step? It cannot be a vague feeling.
Right. It can't just be when the draft looks good. It has to be when the draft is finished, spell-checked, formatted to the standard template, and the budget numbers are verified.
Yes.
If those conditions aren't written down and agreed upon before the work starts, the handoff will fail because the two parties are playing by different rules.
And to prove those conditions have been met, we arrive at the fourth criterion: verify accompanying evidence. What documentation or data must physically or digitally travel with the work?
Because work without evidence is just a rumor. The Lean Six Sigma hub source has a fantastic data point on this.
Oh, a loan processing one?
Yeah. A financial services firm was struggling with massive loan processing errors. They implemented a standardized handoff checklist between the loan officers and the underwriters.
Okay.
This checklist required 23 specific data points that had to be present before the transfer could occur. By demanding that specific evidence travel with the work, they reduced their errors by 67%.
67% simply by defining the evidence. The observable element here is the presence or absence of the required attachments, data fields, or test results.
It's black and white.
Exactly. The question the receiver must ask is, what specific information do I need to actually begin my work without having to ask a single follow-up question? If that evidence isn't traveling with the work isn't ready to travel.
I can imagine some pushback on that, though. A 23-point checklist sounds incredibly tedious for an agile team. But I suppose it shifts the burden of proof, right? It removes the subjective debate about whether something is ready.
It replaces friction with structure, which brings us to the fifth criterion, the most critical moment of the transfer: accept or reject explicitly.
This is where the rubber meets the road.
It really is. This requires a time-stamped status change or a formal acknowledgement. It kills the silent handoff instantly.
It forces a decision.
Exactly. The question is, how does the receiver officially signal that they have taken possession and responsibility of the work? This cannot be a nod in the hallway or an implicit understanding.
A thumbs up in an email doesn't count.
No, it must be an observable, recorded state change. In a project management tool, it is moving a ticket from awaiting receipt to received. It is the moment the baton is firmly grasped by the next runner. If a handoff cannot be explicitly rejected, then acceptance is entirely meaningless.
But wait, if we give people the explicit power to reject work, aren't we just creating a bottleneck? What actually happens when they reject it?
That is where the next part comes in.
That is the sixth criterion: escalate exceptions. Where do missing, conflicting, or unusable inputs go so they don't just die in an inbox?
You have to have a defined routing for failure. The question to ask is, when the ready-to-receive conditions are not met, who resolves the conflict and how quickly?
Right.
If an engineer receives a design spec that is missing critical dimensions, what happens? If there is no escalation path, human psychology takes over.
People get defensive.
The engineer pushes back informally, the designer gets defensive, hierarchical fear prevents anyone from raising it to leadership, and the ticket sits in purgatory.
So an observable escalation path dictates that if a handoff is rejected, it bypasses the interpersonal conflict and goes to a specific named manager who has the authority to resolve it.
Yes, a manager who can resolve the priority conflict between the two departments within a specific time frame. And the final criterion, number 7, record the transfer of responsibility. When did the ownership actually change?
This is the historical ledger. It makes the transition a matter of fact rather than a matter of memory. You ask, can anyone look at this project right now and point to the exact minute the receiver took ownership?
It creates a trail.
This prevents the inevitable Monday morning meeting where one team says, we gave it to you Thursday, and the other team says, we didn't see it until today. The record removes the debate entirely.
So if a team listens to this and says, look, this is all just a communication issue, if we just commit to having better communication between departments, won't that naturally solve these handoff gaps without needing such a rigorous 7-point checklist?
That is a very dangerous assumption. If leadership claims the solution is simply better communication, you have to push back immediately.
What should you ask them?
Ask them, what specific decision, record, or acceptance condition would become different?
Because better communication is an intention, not a mechanism.
Exactly. Does better communication automatically name a single receiving owner? Does it establish a 23-point evidence checklist?
Probably not.
Does it create a time-stamped record of transfer? No. It usually just means more meetings and longer email chains. The Handoff Ownership Check works precisely because it replaces the vague desire for better communication with observable structural requirements.
That makes perfect sense. It's about engineering the transition. And now we want to move from theory to immediate practical application for you, the listener.
Let's get practical.
We are going to guide you through a 20-minute exercise based on this exact diagnostic. You can pause this deep dive if you need to, grab a piece of paper, and let's apply this to your actual operational reality.
This is where we isolate the variables in your own workflows.
Step 1. Select one recurring handoff in your work. Pick something that happens regularly, where work moves from your team to another, or from another team to yours. Don't pick a massive once-a-year project. Pick a standard weekly or daily transfer that always seems to have a little friction.
You are looking for the everyday mundane transfers.
Step 2. Write what the sender considers complete. If you are the sender, what is the exact moment you mentally check out and say, my part is done?
Be really honest with yourself here.
Step 3. Write what the receiver considers usable. If you are the receiver, what exactly do you need to be able to start your work without asking a single question?
Think about that state 4 condition we talked about.
Step 4. Identify the differences between those two viewpoints. Look at what you wrote for Step 2 and Step 3. Where is the gap? What does the sender think is adequate that the receiver finds lacking?
That gap is the silent handoff.
Step 5. Name the specific evidence that must travel with the work. What document, dataset, or sign-off must be physically or digitally attached to the transfer?
The proof.
Step 6. Name exactly who may accept or reject it, not the team name. Write down the name of the human being authorized to make that call.
A single point of accountability.
And Step 7. Record where an unresolved exception goes. If the handoff is rejected, whose desk does it land on for resolution? Take 20 minutes to map this out for just one handoff.
It is crucial to set the right expectations for this exercise, though.
Oh, for sure.
Completing this 7-step map will not independently eliminate delay in your organization. It is not a cure-all. What it does is take something invisible and make it inspectable.
It brings it into the light.
It reveals whether the transfer relies on a defined system or merely on assumption and habit. You are diagnosing the gap, which is the necessary prerequisite to actually closing it.
So what does this all mean? If this diagnostic isn't a magic cure, we naturally need to temper expectations by exploring exactly what it cannot fix. What are the strict limitations of the Handoff Ownership Check?
The diagnostic is highly specific, which means its boundaries are strict. It cannot independently solve problems that are native to the departments themselves or the broader organizational structure.
Like what?
For example, it cannot solve low capacity. If a department simply does not have enough people or time to do the work, defining the handoff perfectly won't magically generate more resources.
Well, that queue is still going to be long.
Exactly. The work will still queue up. You'll just have a very clear record of exactly when it entered the queue.
It also can't solve competing incentives, can it?
Yeah.
I'm thinking of a scenario where a sales team is incentivized to push custom orders through as fast as possible, regardless of completeness. And the operations team is incentivized to maintain 0 manufacturing defects. A clean handoff checklist isn't going to fix that underlying conflict.
Precisely. It also cannot fix insufficient authority. If the person you named as the receiver in the exercise doesn't actually have the organizational backing to reject substandard work without fearing reprisal, the diagnostic fails in practice.
And they'll just hit accept anyway to avoid conflict.
Right. Furthermore, it won't fix technical incompatibility. If the sending department uses a software system that outputs data in a format the receiving department system cannot read, the handoff check won't rewrite the code.
And obviously, it cannot fix poor quality work. A perfectly documented transfer of a fundamentally flawed design is still a flawed design.
Lastly, it cannot resolve deep-seated organizational conflict. If two departments actively refuse to collaborate, a checklist will just become another weapon in their turf war.
The Automation World source on manufacturing startups provides a brilliant lens for this. They talk about decision debt.
That's a great concept.
When a new manufacturing line is being commissioned, the individual equipment might function perfectly. The filler fills, the capper caps, the packer packs. But the line stalls because of unresolved operating decisions. The source notes that a line moves at the speed of its slowest unresolved decision.
That is a profound structural observation. In a modern manufacturing environment, you might have a vision station that detects an anomaly. The equipment supplier says the system is working as designed.
Right.
Operations wants to know if they can run with a manual check instead. Quality hasn't defined who can authorize that workaround. The equipment is fine, but the decision debt brings the entire line to a halt.
So if a 15-minute handoff check can't fix poorly designed equipment or override bad incentives, what is its true purpose?
Its true purpose is to isolate the variables. By forcing you to define ownership, evidence, and disposition for the transfer itself, the diagnostic clears away the administrative fog.
Gives you clarity.
Exactly. If a handoff fails after you have implemented the check, you know definitively that the problem is not a lack of communication or an ambiguous process. You have proven that the problem is a capacity issue, a technical flaw, or an authority constraint. The diagnostic's value is in revealing the true nature of the bottleneck, allowing leadership to apply the correct intervention.
Let's extend this logic. We've been talking a lot about human-to-human workflows. But looking at the broader industrial landscape, this underlying question of ownership seems incredibly relevant when we look at the future of technology and automated systems. These boundaries exist everywhere.
The principles of handoff ownership absolutely scale beyond human interaction. The boundaries just change their nature.
Right. Think about engineering changes in a highly automated environment. When a design modification is pushed through a PLM system, that's product lifecycle management, where the engineers design the specs down to the MES, the manufacturing execution system that the factory floor actually uses to build it, who owns that transfer?
Such a huge question.
Or robotics integration.
Yeah.
You have a robotic arm supplied by one OEM, one manufacturer, dropping a part into a CNC machining center supplied by another, or automated data transfers across cloud platforms.
Yeah.
And especially now, AI-enabled workflows where an AI agent might be analyzing data and handing off a recommended action to a human operator or even to another AI agent. These are massive emerging applications where the unowned interval could cause catastrophic errors.
This raises an important question, and it is perhaps the most critical challenge for the next decade of industrial engineering. When we talk about human workflows, acceptance involves human judgment. But what does acceptance actually mean when the receiver is a machine, an automated workflow, or a software system?
That is a staggering question for anyone working in integration. If an AI system generates a production schedule and sends it to the factory floor's automated routing system, how does the routing system say, "I have received this, I have verified the accompanying data, and I accept responsibility for executing it"?
It forces us to ask how we encode the 7 criteria of the Handoff Ownership Check into digital handshakes. How does a machine verify ready-to-receive conditions beyond a simple network ping?
Right, because a ping just says the machine is on.
Exactly. How does an automated workflow explicitly escalate an exception when the input data is technically formatted correctly but contextually nonsensical? We are rapidly building systems that automate the generation of work, but if we do not rigorously engineer the acceptance of that work by the receiving systems, we're just creating high-speed, silent handoffs.
We are building the potential for automated decision debt at a massive scale. It's a fascinating operational question to consider as these technologies mature. The architecture of accountability has to be built into the software and the hardware integration, not just the human management structure.
The boundary is where the work lives or dies, regardless of whether a human or a machine is doing the handing off.
We've covered an immense amount of ground today, from the local illusion of completion on the production floor, through the 4 states of a system view, all the way into the implications for AI and automation. We've unpacked the visual of the pinched toes and walked through a practical diagnostic to make your own workflows inspectable. But if we distill this entire deep dive down to a single resonant takeaway, it comes back to the core tension we started with. Completed by one department does not necessarily mean usable by the next, which real handoff currently depends on everyone noticing that nobody formally accepted it.